Alright, so today I'm gonna try to do the linked list challenges. I already finished the chapter in the book about linked lists and okay, here. And I think I'm gonna read more the book than do the exercises for now because there are a bunch of other books that I wanna read. And I think I'm gonna buy. One of them is for networking. Or maybe I can show the list here that I made. And I wanna read all these books, and also have to make money to buy them. Where is it? And the other thing that I'm thinking about is I don't know how much I'm gonna spend on each exercise. I don't want to put a timer because I think putting a timer is gonna make me not want to really try to solve it because I'm just gonna be waiting for the timer to see the solution, and that's not good. This is the list I made so far. If anyone has recommendations, I would appreciate as well, so I can research before. But I need one to understand operational systems. I already got one that Olala recommended, and I need another one to study data structures and design patterns. But both of these things, so that would be 3. Then another one to understand networking, because I remember I had some issues with trying to understand URL lib connection pools and how proxies work and the connection between Python and the operational system when making connections. And that's something that I really think is very good to understand, regardless of which area you go to, because everything obviously is connected to the routing and the way that your computer connects to other computers and servers and things like that. So I think that's really important to understand. And that's the first one that I'm thinking I'm gonna get, which is mastering Python networking. It was recommended by a bunch of different channels. So I think I'm gonna get this. Then I'm thinking about getting this pen tester blueprint. And then later on, once I'm done with all of these other books, I'm gonna get one for C++ as well to understand and become better with C++. So because of that, I think I'm gonna spend more time reading than solving the challenge for at least a little bit until I finish this other book. This book that I have here, which is Elements of Programming Intervals in Python. And I was gonna do one chapter for each challenge here. I finished the chapter before I move on. But now I think I'm gonna try at least to read more chapters before I move on to the other topics. But only after linked lists. Given the head of a single linked list, reverse the linked list, and return the reversed list. This one I remember, I think. I'm gonna try to do all of this from the list because I already did them. So it should be easier. Maybe it won't be, but it should be. Because I already know the solution. And wow, or maybe while had the banner. And then if I can do all of them easily, I'm gonna search for other LeetCode problems on linked lists. And I would wanna do them until I feel comfortable that I understand what a linked list is and I can manipulate it and solve the challenges with relatively ease. At the same time, I don't want to spend a bunch of time in any particular topic as well, because I don't have a lot of time to study this stuff and I have a lot of other things to study. So It's always a question of what you focus on. Make sure and don't get stuck on any particular topic. So here I think you have to create a temporary variable to start remember instead of tail they used current. So but obviously the logic is the same. And tail becomes head. Maybe I'm confusing the two. Because there are also previous. And then head becomes head on next. And tail becomes next. No, I'm missing something on this one. So this part I think is correct. You need to make a variable to start the next node. Then thanks for the follow. I don't know who it is, but thanks. This part, I remember I had trouble with this part as well the first time that I redid this. But it's to think about the logic for flipping the shoe and then I think maybe it was head on next equals head. What do you mean by preparing for fall? For interviews you're talking about? KXP Prince. I'm doing this to study and I'm also relatively I'm looking for jobs, but I'm not actively looking now. I think I'll actively look at the end of the year because I'm going to be more prepared. But I'm also looking for jobs, but I don't like this way of thinking of doing this to prepare for jobs because I don't think that makes sense. I think you should always focus on improving your skills because skills is fundamental. Instead of focusing on money or jobs, you should always focus on the cause, not the effect, because you're in control of the cause and you're not in control of the effect. So if you search for interviews, that's a bad state of mind because once you get the interview, then your job is done. But in reality, your job just started after you get the job, if you know what I mean. So you should always be focusing on how can I become the best possible ever, because that's an endless game. And then you're never going to stop because there's always things you can improve on. And that's the way that I think. So another thing is that if I get good at this stuff, then I'm going to do other stuff as well. I'm not going to just do these algorithms. So and this is obviously not going to pass, but I remember I have to store this one. I think this part here is correct. I get the next, I start in a temporary variable the next node, and then at the end I make the tail equals to the next. And it's just this part here that I'm not sure if I remember correctly. Maybe I need another variable here called previous and make it equal to none. I think that's what I'm missing. And then I make previous equals sad and head on next equals previous. Or something like this. That's one of the reasons why I like LeetCode as well. Maybe I do a head on next. Is because LeetCode is more focused on, at least from the very little I did with Code Wars, it seems like LeetCode is more focused on the fundamentals and the principles. It helps you become better at understanding the problems and how to think in a programmer way, let's say, using the data structures and understanding the algorithms instead of code wars where I felt more that is like freestyle and there isn't really, at least for beginners that are learning, there isn't really a structure to know if the way that you're thinking is good or not. So far I like LeetCode a lot more. So maybe it should be tail because I'm moving the tail, not the head. I'm using the head to shift the things. Oh, I need to return tail done next or dummy done next. I'm still getting nothing, so let me think. I'm making the next node equals to this. Maybe but the previous one next. So this part is correct. I have the first, I get the second node, and then at the end, I make the first node equal to the second one. Or maybe it's not actually. Because tail has to be equal to head. I also think there's something here with dot next. Because it's not this way here. It's on the left side. Maybe tail dot next goes next. Let me erase this and think about it again. So I have the temporary variable that is equal to the next one. Oh, it should be head on next here, maybe. Head on next. Then I make previous equal to head. Let me think if that makes sense. Previous equal to head. Yes. And the tail equals to previous. So this works. No. Mm. I completely forgot how to do this. Which I guess is a good thing because then I have to think about it. So what was the point of creating the temporary variable? It's because I was gonna modify it. I was gonna so let me think what I'm trying to do. I'm trying to make it so that the tail is equal to the second one. So tail should be equal to head on next, which is this one. Tail is equal to head on next. But how am I gonna flip them? So this one is the one that makes it move. Maybe it should be tail equals head at some point. The other thing I don't remember is if I should be using two different variables or just one. That's the thing as well. So I have head and head on next. Head on next should be the first. It may be previous equals head. Or maybe here should be tail equals tail done next. I actually think that I don't need this one. That's what's confusing me. Let me just put current because that's the way the solution was. Oh, here's current done next, maybe. But there was a previous in the solution. I remember it was with previous and current. But I don't remember the way that it is switched there. And then was current dot next, maybe equals next. Or just current equals next. Or maybe it's better if I try to think about it, forgetting about the solution. So if I was just gonna replace, I think that's a better way, probably a better way to think about it. If we're just gonna replace on the dummy, it should be the reverse. So that means that the head dot next initial point to heads. So heads dot next initial point to current. But if I do that, then I lose the first one. So I should store on this variable, probably. That's why the temporary variable. And then I need to make current.next equals to head. But I'm not sure, because this, I remember, or maybe I make current equals head, or previous equals head here, and then I make current equals next. And the second one points to the current one, which is the dummy. Then, or maybe that's why I need a different variable. And here's head. Then I make the current equals to the next, which is the next one. And this here feels wrong. This part can't be right either. So maybe just head equals head on next, and then yeah, but then this should come first. It doesn't feel like it's right, but just run around and see if I get anything. Also, apparently, there was an employee from Google that said that there is an AI that's slightly conscious, which is really interesting to think about. I'm not sure if it is or not, but I think we're probably really close to the point that it's impossible to know. And then at that point, it's gonna be things are gonna get really weird. Especially if you're gonna work on these companies, because you're not gonna know if you're interacting with someone or just an algorithm. And even though I understand it's just data feeding, it's unclear to me because I don't know what consciousness is. So it's completely unrelated to the problem. Damn, I'm having a hard time. Maybe it's because the last time I didn't understand really well what's going on. I think these two steps here have to be correct, because I wanna capture the next node in the temporary variable and then pass the current one to the temporary. But this one in the middle, how can I switch there? I don't remember really well. Maybe it was just current equals head on next, but that doesn't make sense. Because that's the last step. The hell, we're supposed to do this. Maybe there was a different variable. Yeah, I think I have a strong feeling that I need another one, but I'm not really sure why. I think I can remember from memory that there at this point I'm supposed to make previous equal to something else. Maybe it's sad, but I don't really know, and I don't remember this one as well. As this part makes sense, if I'm trying to reverse, the current one has to be equal to the next one. And I think there was something that I didn't understand about linked lists that allowed me to make it equal and change the value somehow. And I wasn't really getting that. So maybe that's the thing that I'm having difficulty with here. Maybe it was something like this, current equals sad. Or, but I feel like this previous equals sad makes more sense. Oh, head on x equals previous, maybe? And previous equals sad. But that's gonna generate a loop, maybe? Previous equals current. And then I return previous dot next. Let's think about this. So I have a temporary variable that is equal to the next one. So this is gonna be equal to true here in this case. Then I'm making one point to the none, which is the previous one. And then I make it, yeah, this line doesn't make sense. Because I'm making the previous equal to the current. It also doesn't make sense for me to make current equals to head as well. Because it should be equal to the next one. Yeah. Maybe I should try to think about how would I switch if it's just two nodes. If it's just two, then the current has to be equal to the head. The thing that is stopping me doing this is that I think I remember I didn't have two currents here. But maybe so the current needs to be equal to the head, which is the first element. I know, that should be the last one. So in the first list I have head pointing to head on next. I need to make head on next, point to head. And maybe this will help. Yeah, but that's what I'm doing here. I'm making the current point to head on next. So maybe here I should change the value of head on next at some point. That's the confusing part. Because if I change head on next, I can't move. because it's gonna be stuck on a loop. I change. So maybe I should do current equals head on next. That doesn't make sense because that's what I'm doing here. Next, goes head on next. And the only way to move forward would be this way. What I can think. But I have the intuition that it's not gonna be like this, that I should move forward to the next one. And I also have an intuition that Brav is gonna be equal to something else here. If I make previous equal to current, it doesn't make sense. Or maybe it does actually. Because current is not changed yet. Hey, Olala. Uh, no, I think I'm fine. I'm just gonna think about it. If I get stuck for too long, then I'm gonna look at the solution. But if I don't struggle, then I'm not gonna remember. That's the thing. It's because the first time I did this, I didn't really force myself to understand this part in the middle here, how it works. And then you just forget. That's the issue. Okay, so I have a temporary variable here to start the next one. Then I'm making the current equals that here. So I think that's where the switch happens. And I need to change the value. I need to change the value of head.next at some point, I think. Because it wouldn't make sense to have the temporary variable if I'm not changing the next value. So head.next equals current. Maybe that's the thing. Let's see if this works, but probably not. And it's gonna be tough. I know that. Especially if I get stuck. And that's how it's supposed to be when you're learning things in the beginning. Kind of sucks, but then becomes better once you understand what's going on. So I'm creating an infinite loop because I've had done next there. So maybe should make it equal to previous and then previous equals current. So I take the value of the next one, make it equal to none. And then I make the previous equal to the current one. Maybe that's the one. That's the way. Let's see if I return current or dummy the next. Okay, so at least some improvement. At least I'm seeing something there. And this one doesn't change anything. Hmm. I'm also not changing the order in this way. See if I do like this. So it runs into an infinite loop probably because the last one is pointed to the beginning one. Yeah, because I'm making previous equals to current. Maybe we should do current done next. Equals to previous. I think I need to make to jump somehow, but next one is the next. Make current equals to the next. So it's kind of like I'm taking this one and putting here. Oh, that might be the way because current on next equals to previous. And then this equals to head, maybe. Let's see if that works. And then I put a different condition here. Because the question is, how can I move the head forward so I get all the values, but indirectly? And this shouldn't be current on next equals previous. The current should be equal to previous. But that doesn't make sense as well. Yeah, I don't think this makes sense. It's the only way I can think about moving forward is ahead equals head on next. Maybe I should try to come up with my own solution instead of trying to remember the one that they did it, because that's gonna be better to understand the logic behind it. Instead of one pointing to true, I need to make true pointing to one. How can I do that? 0.h1. It's the stuff that I was talking about. This current should be equal to head on next. Current. And current on next should be equal to head. That's the thing that I'm missing, I think. Current on next should be equal to head. Yeah, the next one should be equal to this one. The previous one should be equal to true. But then how do I move the head here? Shouldn't it be head equals head on next? And this is not gonna pass, probably. Maybe it's while current. So why would I need to store this one? If I make head equals head on X here, I wonder if that's gonna work. But then I wouldn't need this variable. Or would I? Because I can just make this equals head then. Current on next equals head equals head on next, current equals head. And so this creates an infinite loop as well. So I'm making the next one out of this. Oh, that's the problem, I think. Because I'm making the next one out of current equals to the head. Then I can't change the value of the first one. Maybe. I'm not gonna be able to print if it's an infinite loop. Or maybe yes. Okay, the first is 0 and on. So when I assign current tree equals to head, it changes the value of the head somehow. It should be head on next here. was because I'm making current equals head.next and then current equals head, current.next equals head. I still don't understand because if I'm changing the value of the head each time, what does the head have to do with the other ones? Oh, it's because I'm making current.next equals head here. I think what I'm having a hard time with is understanding. I think there's something about making this point to this that changes the value of the head. And I'm having a hard time understanding that. I should think about it as an object. So current on x equals and so when I change the value of the head here, it changes the current on next as well. Because it's an object. And when I make current equals to head, because this one is attached to that one, it creates a cycle. Yeah, because when I change this one, I'm also changing this one, the current on next. And that's what creates the cycle. I think now I get it. It's super confusing. So that's why you need the temporary variable, but I still can't think about, because, yeah. It's confusing because you're changing an object, not a variable. So the reference is different. It is different, and it's hard to think about. So what's the difference if I store in a temporary variable? What's the difference? It's when I modify the value of the first one, it's not gonna modify. I'm gonna try to remember the other way. Maybe the previous should be equal to the current. Something along those lines. biggest issue is that I can't think how I'm gonna move the head without reassigning the value of the head. So maybe this should be while current, not head. But then still, because I need to move through the head to get all the values of the first one. What's the point of having this previous here? Let me remove the line and try to think with the other ones. So I have the head on next here. I'm gonna make it equal to the current one. So I'm making 2 in the beginning here. Then I'm making this one, which is current on x equals to the head. But how I'm moving the head here? Doesn't make sense. Unless I make head equals head on x, but I know that's not the way. It's not gonna work. Maybe I should try to think how I would do it if it's a variable to pass one reference to the other. And create a temporary variable. Say I have variable b. Make equal to temp. Then how did I do it there? I don't remember if it's b equals a. Yeah, b equals a. Then a equals temp. So maybe I should do current equals head. I have to make head on next equals current. Maybe. But then this line doesn't make sense. So maybe that's the thing that I'm not understanding or not remembering from the first one is that making head.next changes the value of the current as well. Because now head.next is pointing to current. Which is the beginning of the first one. So maybe it shouldn't be head equals current. Yeah, that's why I need to do this one. Because if I'm changing the value of the head, then I lose head.next. That might be the thing. Head equals current. But then what do I do here? I also don't remember if I have to use this prav here. Maybe it was head equals prav and then prav equals something. Prav equals current or something like that. I don't think this is correct, but I can't remember really well. It doesn't make sense to change. You start the head.next in a variable and then not change it later. The biggest problem I have is I can't see how I'm gonna move the head if I don't directly change the value of the head. And then I think that's what I'm having trouble understanding. Head.next should be the beginning of the previous one. And doing something like this also doesn't make sense to me. Which Yeah, it doesn't make sense. I was gonna put next here and then previous equals previous dot next, but I know that doesn't make sense. So let me go back and try to think from the beginning. If I was just gonna try to reverse, I would make current equals head dot next, and then current dot next equals head. What's the problem with this? So I know I need this thing here in the middle, and then I need to start this variable here. So maybe it's previous equals head dot next there. And then instead of making equal to head, I make equal to previous. Yeah, maybe that's the thing. So head dot next. And then previous equals this. No. Alright, jump this one here. Know if it makes a difference or not. Current equals next. But that I don't think this works as well. Previous dot next equals head. Yeah, because I'm gonna create a cycle. I'm gonna go back to the other one because I felt was getting close to coming up with something. So current equals head dot next. So current is equal to 2 in this case here. And then the next one is equal to 1, which is what I want to do. So what's the problem if I do it like this? And then I just make head equals head dot next here. I think I tried this before and then I got an infinite loop. And I think it's probably because I'm changing the reference of the head when I make this equal operation here. Current equals head dot next, current dot next equals head. Because I need to change the value of the head maybe. Because 2 is pointing to 3. I need to make 2 pointing to 1 first. That might be the reason. Yeah, because I'm not making current equals 2, I'm making current equals this whole thing here. So I need to make head on next point to the previous one. And then I need to make current equals prav. our current.next equals proud. But I know that's not the solution. It's from what I can remember, I'm not supposed to do two different .next on this side here. There was only one, I think. So if I make head.next equals previous, I make... Yeah, but then I'm changing the value of the head.next. Maybe I should search for what happens when you reassign. Yeah, but it's a difficult thing to search for as well. The biggest issue I'm having here is understanding how reassigning the value of an object changes the reference in memory, or changes the object itself. That's what's confusing me, I think. Because it should be simple to do this. But for some reason... hey, Jack Flapper. It's just really confusing for me to think about. Uh, what should know the example? Modifying this for true. I'm having a hard time thinking about the changing reference from them. It's just messing up my mind. It's also something that is naturally confusing to me, even if changing values of variables using a temporary one. But with objects, it becomes a lot harder for me to think about it. 1 and 2? Yeah, I did this, but I can do it again. I think what I have to do is make current.next equals to head. And then current equals to head.next. So that way, this one becomes the next one, and the next becomes the first one. But I know that doing this is gonna change the, and I'm not really making it equal to 2 because head.next is this entire thing here. Head.next. And once I make current.next equals head, I'm also making it equal to the entire thing. Because head is all the... But I can't think about a way because I have to change the value of head maybe to previous. And storing one of them, the previous value. But then how do I move through the head? Maybe it was next equals current.next instead of head.next. But that, no, doesn't make sense. Why do I need 2 different lists as well? Maybe it was something like head equals previous, previous equals current, next was head dot next, current equals next, or next. Because they go on zigzag there, I think. So next is equal to this one. Then I make the head equal to point to there. To none. Then I make previous equals current and current equals... Maybe that's the way. But then am I changing the value of the head here? I'm making equal to previous, so it's gonna stop in the first iteration. So maybe I have to do while current. Because the last value... But am I moving current here? So head equals this. That's the issue here. I don't move through the head. That's the problem. Because I'm reassigning the same values. So maybe I should make head.next equals previous. But then I also think I'm not gonna be moving through the head if I do that. Yeah, that's what I thought. Maybe it should be current on next year. And then previous equals set, maybe. But I also think that doesn't make sense. Yeah, this doesn't make sense. Because if I'm making period on x equals none, then it was something along the lines of this. Equals set. And I know I'm missing something really obvious here, but I can't remember. Because I remember the last time I looked at the solution for this, I understood the logic behind it, and it was something really obvious that I was missing. That for some reason I couldn't think about. And I think now I'm stuck on the same point. Because I remember it moved through the first one based on this logic in the middle, but I didn't understand how the logic in the middle was moving the first one. And it's probably because of this reference thing that I have a hard time to understand. Critical sound. So maybe I should try again, forgetting about the other solution. I'm trying to think if there's a way for me to search this as well, this reference thing. But I can't come up with a good way to search this, to understand how the reference changes when I change the value of the list. I'm stuck on this because I can't seem to. Yeah, the only way that makes sense to me is to change the value of the head directly, like this. Add on next. So I move through the head first, and then I change the values based on that. But I know this way doesn't work. So maybe I should try to go about building the solution from this point instead of trying to remember the solution from the end there of the first time that I saw. So I have the current, but the issue is, yeah, so maybe I'm gonna spend more time trying to understand why this one doesn't work. Current has to be equals to add on next. And then current on next, that should be equal to add. Why doesn't this work? Let's see if I can print this. So add on next is this part here. And making current equals to that. And the issue is that I have to change the reference of the head on X first. And that's what's confusing me. So, and that's probably why you need the previous. So you change the value, maybe. Because previous in the beginning should be none. And then head.next should be point to none. But that's not the beginning value of the other one. That's the thing that I'm confusing here, I think. Yeah, that's the issue. That the reason why I'm not being able to think about this is because when I assign the value, I'm assigning all the other ones. It's not like I'm just getting true and then making the current equals that. I'm making equals to all the references that come after that, and that's why it generates a cycle there. But it's difficult for me to think because how I'm gonna change the value of the head.next to just point to the head. So maybe head.next equals head. That's what I should do. Head.next equals head. Yeah, but that doesn't change anything because head's gonna point to all the other ones as well. So that's the issue I'm having here, I think. Is how do I change the value? How do I assign the value without assigning all the other references? Oh, I think I can just sprint and see what happens. It's probably a better thing to do. The fundamental problem I have here is understanding that. Because when you reassign the value of a variable, it just changes the value. But when you do it with the linked list, I'm not sure. Because I need to change the pointer. But how do I change the pointer? Because if I change the value of 2 and make it point to 1, then I'm just gonna make a cycle because the 1 is pointing to all the other ones as well. So maybe I need to cut the connection first, make head equals previous. So head points to none. And then I make head current.next equals head. Equals head. But that doesn't make sense because then I'm putting the value of the head here. So how do I make 2 point to 1? Oh, it has to be pointed after I change the value of the head. But if I do that, then so if I make head.next or current equals head.next and I change the value of the head, then I can't get this. So maybe that's why I need the temporary variable. Next equals head.next. So I store the value of this node, then I change this one. And then I change this one. And then I make previous equals to current. Maybe that's the way. But I still don't see how I'm changing the first value of the head. So I think I'm gonna look it up. Current.next. At least it runs. So now I have add equals to none. And I have this value. At the end, oh, so this, so the thing, I think the reason why I'm making a mistake here is because I'm trying to change both values at once. And I should just change one value. That's why. Because I'm trying to think about how to make current and current.next in the single iteration change. But I should only be changing one of them at a time. That's the problem. So I feel like I'm making progress, and it's helping me clarify the confusion I have about this. Hopefully I will be able to make it work without looking at the solution. So I have next here. Next equals to, okay, then I change the value that I had to none. And I'm gonna make the current point to that. So maybe if I do add here, but that doesn't make sense because I just changed there. Maybe current dot next. I think I'll be right back when I go to the bathroom. And the thing that's is bugging me is that I remember that at some point, I think that this should be next year or something like that, but I'm not really sure about that. And then here should be previous equals something. I'll be right back. So I need a way to move through the head here. If I make head dot next equals previous, I don't think that makes sense. Because I'm just cutting the loop there. So to me it makes more sense to make head equals to previous, because, and then store the values of the initial head on the previous equals head on next maybe, but or should this, but I also don't think that makes sense. If I make head on X equals to previous and then previous equals to head, but let's type this instead. So I'm storing this true value here. I'm making the current equal to this one. Maybe I should be current on next. Equals sad, maybe. And then previous equals something else. Once upon a time, I told you to do binary search, IIRC, or was it another streamer? Yeah, I don't think it was me, man. Thanos back. I think you were the guy, if I remember, but I might be mistaken, of the Uniswap paper. If I recall correctly, okay. I'm having a hard time with this problem here. It is an easy one, but for some reason I can't think about it correctly. I know there's something really obvious that I'm missing, but for some reason I can't think about it. To make current .x equals sad, that makes sense. And then I make current, maybe this is the approach. Huh. The only thing here is that how the hell that I'm gonna move through the nodes in the head. That's the thing. If I just the previous here, it's probably not gonna work as well. Yeah. Maybe this is equals previous. Maybe here current. What? Binary search can visualize how binary trees or linked lists look like based on the output. And binary search isn't hard, there's easy and hard problems. Oh yeah, I really like binary search from what I've seen from other streamers doing. But I think I'm gonna move on to that one once I go through the LeetCode problems, at least a few of them. Because I separated by topics here. Let me show. These are the topics that I have to go through. And I think through each one is better to use LeetCode because LeetCode has the topics separated here. And I can go through these problems. And I think it's good to struggle, especially to show people because it's part of the process. So I search with viewers too. So yeah, I'm gonna do binary search eventually, but I think this problem shouldn't be hard, and I remember the solution, and I know that it isn't hard, but it's just something that is important for me to struggle through it because I have to understand there's a big fundamental gap in my knowledge, in my understanding of the way things work, and it's probably not only related to linked lists, it's related to the references. Because I think I kind of get it, but apparently not. When referencing objects, changing the reference of objects, I have a hard time thinking about that for some reason. So maybe it's the way that I'm thinking that, the way that I'm visualizing in my mind. There's probably a better way to do that. That is not so complicated. And that's what I'm trying to think about here now. Like what is the reason that is making me, and maybe the solution, because I saw the solution, is messing me up because I didn't really think through it the first time. I went with the solution, so it's like I just have the end, and I didn't go through the process of understanding how to arrive there. You should do while current. I don't think that's the mistake. Because if that was the reason, I should be getting something when I return current.next. And I'm getting usually an empty list there. If not, next node is exits, then reverse it, right? The last element. So this I'm going off based on the solution that I've seen the first time that I did this, that I tried to do this. Which is pretty much a start. So to start the list, to reverse the list, I think I should do current.next should be equal to head, and current should be equal to head.next. But then if you do this, for some reason, it messes up because when you do this, you're changing the value of the head as well. So you need to store in a temporary variable. And then you use this temporary variable to store the value of current. because current is going to be true in this list, so it's head on next. The first element, or you're trying to switch, make true point to 1 instead of 1 pointing to true. And that does that. But then in the middle here is why are you creating a new list node? Because I want to store the reversed one on this new one. And this other one I remember from the previous solution, but I'm not sure if it's necessary or not. Yeah, but I don't think that's the issue though. Yeah, this I'm pretty confident that is not the issue, the dummy one. Because you use the dummy to reverse the first one. Print car. It's gonna be, but I'm changing the value. That's the point. Aren't referencing choker. What I'll do next? Yeah. The last two? But I think they are necessary. Which ones? Run now? I think this portion here is correct. I'm creating the temporary variable and then I'm assigning that the current to the temporary variable. But then each time I think I should but how I'm gonna do that? Because the current one, the first iteration becomes this thing here. And then I need to make it point to the 1, I think. But how am I gonna do that? Oh, I need to make current on X point to head, I think. The input is a list of, it's a linked list. So in this case, I think it's this list here. This list here. 1, 2, 3, 4, 5. So it only passes the 1 first, which is the head. The head points to the 2 points to the 3 points to the 4, so on. And you need to make the 2 point to 1. And do this for all the nodes. So you're only reversing the pointer to 1 by 1. But if you do that, if you try to do it directly, then it changes the value. You lose the value, I think. And that's why you need a different list. If you try to make true point true, because you need to change the value of the head first, I think, but I'm not really sure. So next equals add on next, current on next equals add. So I'm making this second value equals to the head, which is the first, but the head is gonna be, I need to change the head first. That's the thing. There's probably a small difference. Are you sending me the solution or? I'm not sure if I want to look at the solution yet. I want to think through it and understand what I'm doing wrong here, the way that I'm thinking that is wrong. I'm not gonna look at the solutions yet, man. I wanna try to think through it. Let's step through this and try to understand what's going on. Oh, help me walk through it to see if I realize. So I'm gonna talk about it the way that I'm thinking, and then you can point out which part you think is incorrect. So I think here I'm creating a temporary variable to store the value of head.next, which is this show here. But then this is the thing that I'm having a hard time with, because if I make current.next equals head, then I'm gonna make it equal to this entire thing here. And that's not what I want, I think, because I just want the value. That's the problem. So I need to make head.next equals none maybe, or equals previous. But that also doesn't make sense to me. Is this same reverse list? What do you mean? Yeah, it is the same. Yeah, thank you. But no. I think it's fine, man. I don't have a problem with struggling, or I think you should embrace that. Because there's clearly something that I'm thinking wrong here. And if I just look at the solution, as easy as it might be for you to do it, then, or if I do what your guys are saying, I'm not gonna get better. I'm just gonna I don't like that. I think I need to think about it and try to understand the way that I'm thinking, the way that I'm approaching this, why it's wrong. And that's what I need to solve. And I should probably spend time trying to solve this, because that's how you improve. Yeah. That's it isn't right or wrong. That's what I'm saying. Is kind of like using straps in the gym. Yeah, you can use them to lift heavier, but then you rely on the straps. I'm the type of guy that don't like to use straps. I just like to go with my own hands. But that doesn't mean that using the straps is bad. It just means that's a different approach. And both of them have ups and negatives. The downside of my approach is that I spend too much time on this one, but I think it's worth it. Because I also think doing like this forces me to think about the principle behind it. Not just this solution, but so here I have had next, which is the next one. Then I'm changing the value of that to previous, which is none. So I'm making true equals to none. So maybe should, yeah, but that, I think I tried that before. So if I make head equals to the previous, which is none, then, but then I break the thing. Hmm. Yeah, maybe you're right. I don't think I should change the value of the next one in this. I should try to think if I'm reversing them one by one. So the current is gonna become next. Then I need a way to store the value of head. Or maybe not. Let me think. Does it contain anything about the solution? Oh. Yeah, man. And thanks for this, but the reason why I'm spending a lot of time on this is because I don't think it's a problem with this problem. That's the thing. That's what's going on in the back of my mind. I'm not thinking about this problem specifically. I'm thinking that the fundamental issue I have here is understanding how changing the reference of objects changes the object itself. And I'm trying to understand why I'm having a difficult time understanding that. That's the biggest problem. And that's the biggest thing that I'm gonna get out of this exercise, I think. Because that goes beyond of linked lists, I think. It's just I think there's a fundamental issue there. That's the way I think about it. And it's probably because it's something that I've seen before and that people talk about, that in programming, the equal sign is not making the value equal to the thing, is making it a reference to that point in memory. And because of that, because of the nature of linked lists, it makes it really hard to think about what is happening to that object, that reference that you're creating. And that's why I'm having a hard time with this one. It's not because necessarily, but yeah, these things are related, but I don't think drawing this stuff is gonna help me understand that. That's the problem. So I think I'm gonna search for stuff around that, but the other thing is that I'm not sure how to search for this kind of thing because it's kind of a nuanced thing, so it's not easy to search for. Because the ways that I'm thinking in my mind, I'm not gonna get any good results. It's just gonna be stuff explaining the basics. Or maybe if I search for how to change the reference, changing, yeah, but I don't think that's gonna work as well. And the issue with just looking at the solution or visualizing other stuff is that I know that I'm not gonna remember because I already looked at the solution one time. So the first approach that I did this, I did exactly what your guys is saying, is that if you're stuck, just look at the solution or anything like that. But now, after I did that and I understood the solution the first time, and then I'll go back to it and I see that I can't do it, it is because it has there's something more. I wasn't able to grasp the concept there. And I think that's the difference between the approach that I'm taking and the approach that most people take when they do LeetCode or stuff like that, is that they are more concerned with solving the problems, which is fine, true, is a different approach, but I'm more concerned with understanding the gaps in my thinking and trying to change my thinking instead of trying to become better at solving these problems, because they're connected, but changing the thinking is fundamental. So here, pretty much what I'm stuck at is that if I change the value of 1, if I make current equals next, which is head on next, I'm gonna make it equal to this entire chain here. But then I'm not making this node point to the first node. So that would have to happen in the next iteration. So I probably need to change the value of the head somehow. But if I'm not moving through the head, then when's the loop gonna stop? But I think I'm close to the solution in the way that I'm approaching this now. It's just figuring out how to change the value of the head each time. And that's why the other list is necessary, but I'm not sure what I'm getting correctly here. Because if I make head, maybe I need to change the true values of the current at one iteration. Let's see. Next, equals this, equals true. Then add previous, which is not. Yeah, this stuff here doesn't make sense. It would be head on next here. Because the point is not to solve as many problems as I can. The problem is become better at thinking. That's the thing. But if I make head on x equals previous, I'm just gonna make it equal to none. Which doesn't make sense. Or previous equals head. So previous becomes 1. Maybe you should search for what happens when you reassign the value.
So a linked list is kind of the first serious data structure you learn about because it's very simple and it's actually got a structure. I mean, an array's got a bit of structure, but a linked list
You're
is
saying here?
slightly more complex. We can do.
I should make it. That's the other thing that I don't know. Should I change both values at once for each iteration or just one value? So maybe current on x equals head here. So it's both that thing that I don't understand really well, and the other thing is how does it move through the head nodes if it's not changing the value of the head nodes in each iteration? Oh no, don't show me the solution, man. When I feel like I reached the point where I'm not gonna improve my understanding by trying to think about more, then I'll look at the solution.
Some more interesting things with a linked list.
But I'll take out whatever amount of time I think is necessary.
A linked list is made up of nodes. Each node stores an item of data, so it could be a number, it will be in our example, because it's easy to write, and it has a reference to the next node in the
That's
list.
the error you come upon while interpreting the code. Oh, okay. I thought you were showing me how to do it. So you're saying this line is wrong. And equals to previous. Yeah, that line I'm only putting here because I remember from the other solution that it was something like this. I remember that I had prev here and then equals to something else, but so let me think about this. So maybe it's previous equals next, but I don't think that makes sense as well. Because the issue, how am I moving through the head nodes? It should be through the previous. Maybe current on next equals head. But that doesn't make sense. Let's make it in this line and then change the value here. Current on next equals head. But then I have to change the value of head to previous there. But then I have to change the value of previous each time, I think. Which doesn't make sense. And this is not right. If I make it like this, let me see what I get. It's probably gonna be the infinite loop thing. The other approach to solve this is probably to but maybe that doesn't work. I was gonna say append into another list the values, and then I can count how many times the list has, how many items the list has as well, and then do the reverse. But I think I'm gonna watch the video and then
If we wanted to store
keep
the numbers
thinking.
1, 2, 3, and 4 in a linked list, it would look something like this. Each node stores a value and a pointer to the next node. So the value is 1, then we have another node with 2 in it, and the first one points at the second one. And then if we want to have 3, we can add that.
Where do you put the link? Is it in the new thing, or is it?
No, if you're adding things at the end of the list, the link goes from the existing node to the new node. If you're adding things at the start of the list, which you can do, which you can't do with an array, because where do you put it? You've got nothing. You don't have access to what's before that in memory. You're going to trample over something else and cause problems. If you want to add a node at the start of the linked list, say you want to add 0 to this list, we could just create a new node somewhere. It doesn't matter where in memory it actually is. They don't need to be next to each other. These arrows can just point to anywhere else in memory. So if we wanted to add the node 0 to the start of this list, we'd just create a new node, put 0 in it, and then point it at this element. So in the linked list, we have 2 special nodes. We have one called the head and one called the tail. So the head is the nodes at the start of the list that points to everything else. The tail is the node at the end of the list that is pointed to by the previous node and points to nowhere. In general, with a linked list, you need to keep track of at least the head. The tail is kind of optional. You don't have to keep track of the tail necessarily. So this node is going to be the head of our linked list. So we'll have some reference somewhere, probably a variable called head that points to this node. So if we want to find things in the list, we can go to the head and then we look at its next pointer, and this one's next pointer, and this one's next pointer. The last element in a linked list, the tail of the list, you'll notice this doesn't point anywhere. Conceptually, there needs to be some value here. We can't leave it as uninitialized memory because it'll be an arbitrary number. It will point to somewhere, who knows where in memory. And if you follow that link and try and interpret it as a node, you're probably going to make your program crash. What we do is we point it at null. So in C or Java, it's called null, or it'll be the number 0, like a memory address 0, which is interpreted as null. Or in Python, it would be none. I think it's null in most languages. If our node points to null, then we know it's the last item in the list, which is nice. We know when we've gone through the whole list and found every element.
Kind of reminds me a little bit of a sort of treasure trail where you find something and then it tells you where to go next.
Yeah, I guess it is like that. So yeah, I mean, similarly to that, you can't find a middle clue without having to find one before it. So with a linked list, you don't have random access or constant time random access to the elements. So if you wanted to find the last one element in the list, you need to start from the start, keep counting forwards, probably until you get to the last one, and then it was one before that. I mean, if you want to get to the 10th element, you have to go through 10 times. So in an array, you can access the 10th element really easily. You just say, get me element 10, it multiplies the width of the variable, or the width of the item by 10 and jumps that far in memory. With a linked list, you can't do that because they're stored in arbitrary places in memory, you don't really know where, and you can only get to them by following the links. So if it's the 10th thing, you've got to follow 10 links. If it's the 1000th thing, you've got to follow 1000 links.
Because they could be buried anywhere in however many gigabytes of RAM on your computer, is that right?
Yeah, these could be anywhere in memory, you could be jumping around all over the place. Yeah. That's the only way to get there is to follow the links. Sometimes we might also want to maintain a reference to the tail as well as the head, so we can just point tail at this last element, and this helps us if we want to add elements to the end of the linked list, because if we know where this node is, we can stop it pointing at null and point at a new node, and then point the new node at null.
What happens if you need to add something in the middle of the list?
Or let's say we want to add the number 26 in between 1 and 2. Just, who knows why, but we want to do it. So what we need to do is create a new node somewhere. Doesn't matter, let's put it here. That contains the number 26. We need to break this link, so that's no longer there, and we add 2 new ones, one pointing from the node 1 to 26, and one pointing from node 26 to 2. If we wanted to do this in an array, what we'd have to do is we'd have to shift every element after 1, down 1. That would take n operations, and then put the number 26 in the gap.
That's what I'm having difficulty understanding, is how to break the link. How does that work? I think it's by reassigning the value, but I don't understand really well. And I think it's the same issue I have with nodes or with trees, is that it's hard to understand when you have a nested object like that, where the values of the object are dependent on that object. You can't just think about, when you're changing the value of that object, you can't just think about the object itself, you have to think about other connections as well.
We just made by moving the 2 along. So with a linked list, after we found the place we want to insert the nodes, it's constant time insertion because we're breaking one link and creating 2 more. And that doesn't matter how many nodes there are in the list, we're changing 3 links, breaking 1, adding 2. Searching may take up to, if we want to insert after an element with a value of 3, we're going to have to search through the whole list. And that will take up to n, so up to the number of things in the list. The actual insertion is constant time. Also, if you want to remove an element from the list, that's quite easy too. What we do, we'd break these 2 links, and then we create a new link, joining 1 to 2 again. There's a slight special case for inserting and removing. If you want to do it at the head or the tail, you need to change the head or tail reference to point to the new node that is the head or tail. So if we wanted to remove the first node in the list, we would break this link, we would break this link, and then we create a new link from head to the new head of the list. Similarly, if we insert, we'd point head at the new node. If we delete the tail, we point tail at that node. Create a new one, we point it at the new node. These linked lists we've looked at so far are called singly linked lists because they each have a single link to the next node in the list. Now, there are also doubly linked lists. So a doubly linked list has a link both to the next node and the previous node. The nodes are slightly different. They now have 3 compartments, I guess. So we have the value still here. So we've got 0, 1, 2, 3. Each of these has a pointer both to the next node and to the previous node. So next, previous, and of course, not forgetting that goes to null, and that goes to null. So you can kind of think it's a breadcrumb trail, but it goes both ways. So if you want to, you can start at the head and go down to the tail, or you can start at the tail and work your way up to the head. Still, you don't have very good random access because you've either got to go from the tail and backwards or from the head and forwards. Okay, so a practical example of where I've actually used a doubly linked list in almost the real world. In your web browser, you visit a website, you click some links, you go to a next page and a next page and a next page. And then in the top corner, you can click the back button and go back a bit. And keep going back. But you can go forwards again. And then also, you might go back a bit, you might click another link. Let's see how this works as a linked list. I'm just going to draw the data compartment because it's easier. So we start with main page. At the start of the list, this points to null. This will also point to null as soon as we browse somewhere. So yesterday I was looking up on Wikipedia, there was a link to NASA on the front page, so I went to look at NASA. So this points back to here, this points to null, because we're browsing NASA. And then I read a bit about NASA, Apollo 11, and we click a new
It's not going to talk about
future that you...
that. And the tricky thing is that I have to search while being careful that I just don't look at the solution. And that's why it's hard to search for the thing that I'm trying to get at, because I know that these videos are just gonna talk about the solution, but they're not gonna explain how does it work, why does it work the way that it does. Maybe this one is good as well.
Many of you may be familiar with linked lists. They're commonly used to hold lists of items, in the same vein as arrays. But how do you know which one to use and why? I don't mean just some guidelines on when to use one or the other, but understanding fundamentally the connection between these data structures and the underlying memory. What are linked lists? In the most simple terms, they're a way of storing several items at once. Typically in code, you'll have a situation like this where you want to store a bunch of junk. Let's pretend we have a linked list class, so const name equals new linked list, and names.add, fry, names.add, Zoidberg, names.add, etc., etc. Where names is a linked list, and I've added 4 names to the linked list. And now I'm able to traverse it, search for items, that sort of thing, instead of having 4 separate variables. In other words, avoiding this situation where you have const name 1 equals fry, const name 2 equals Zoidberg, etc., etc. These just seem like arrays with more steps. A little bit, yeah. I mean, they're both collections of items, but let's talk more about the underlying memory. If you think about memory as this gigantic series of slots, each of which holds 1 byte, and this is all ordered sequentially, there's a few ways of kind of rationing out memory that emerge pretty naturally. Imagine your family is out to eat at a fancy restaurant. So your party arrives and you ask the maitre d' for a table for 4. There's room, so you all get seated at a nice table far away from the bathroom. A little bit later on, your friend Bob and his family drops by, so you need some extra seats. There's a few natural options. If the table you're at had some extra room already, by chance, then just sit down, no problem. If the table had no extra room, then what can happen is that the maitre d' can find a bigger table that can accommodate you all, and then seat you all there together. And finally, in this example, they can seat Bob and his family at a new table instead, and just let you know where they are, so you can say hi or whatever. Memory isn't that much different. You've got your layout of memory here, and I've already allocated some memory to store some items. But if I want to store another number, then there's a few common ways I can do this. If there's some more room in the piece of memory that I've been assigned, I can write to the end. But if there's no more room, I could ask for a bigger piece, copy everything there, and then write my new thing in. And finally, I could allocate a new piece of memory, and then in the new piece, I can store the new data and an address to the first chunk of data. And this is what linked lists are. Let's draw some more pictures. In more concrete terms, you've got these fragments of memory. Let's call each of these a node. And a node is structured so that it has 2 sections. The first section will hold the data you want to store, and the second section, which I'll call next, will hold the address and memory of the next node in the chain. So let's say I'm storing numbers. That means I can allocate a node, which gives me a chunk of memory. I can write a number into the data part and leave the next part empty. And then, when I want to store a second number, I allocate another node. So let's say I got this little block of memory now, and I write the number into it. And then in the second part, the next part, I write the address of the first block, forming a chain with this new node as the head. And it should follow that I can keep doing this. Keep allocating new nodes.
Maybe I think I found a way to search. What happens when you change the value of a nested object? That's the question I have. I think that's the biggest issue here.
In there, and the chain just keeps growing organically. So are these better than arrays, or worse, or what? To understand that, we need to...
It's not necessarily related to the solution, I think, but it's just the way that I'm thinking about that. The process in my head should arrive at some solution, the steps that I'm taking. And this is the issue that I'm having, I think. That I'm not able to understand how reassigning the value of the nested object is going to change all the other ones. That's the biggest issue.
Understand how to do basic operations with them. The first thing we'll talk about is traversing the list, just visiting all of the elements one by one. Arrays are obviously pretty simple. Loop over one at a time, incrementing an index. But linked lists are a little different because of their layout and the fact that they're not guaranteed to be contiguous in memory. You start at the head node and move to the next item in the chain. You look at the next pointer, i.e. the address of the next node, and you continue following these pointers over and over until you reach the one that points nowhere. The code will look something like this. So beginning at the head node, we'll have a loop where we assign cur_node equals cur_node.next, and then we terminate the loop if cur_node is null, meaning we've gone off the end. And as you can see, here's the C++ version, here's the Python version. They're all basically the same thing, a simple loop with some checks. It stands to reason then that searching in a linked list is basically traversing the list, checking each item in sequence until you find what you want. But here's where things get a little interesting. Let's delete an item from the list. Let's say I want to delete this item in the middle here. What you do is you perform a little surgery, taking the previous item in the chain and point the next address to the node after the one that you've deleted. That's it. It's effectively out of the list now. Adding a new node anywhere in the list is the same deal, but backwards. To add one, you allocate a new node, change the previous node's next pointer to point to your
The other example there that he gave is also something I get how it works, but I don't understand, because if you're just reassigning the pointer to this one, don't you have to delete this one from memory? Because in reality it still exists, it's just there's nothing, or maybe it's gonna be garbage collected, I think. Because when you break the link between this one to this one, no, but you're not breaking the link to this one, from this one to this one as well. That's the thing. Yeah.
new node, and then change your new node's next to the next node in the chain. The description might be a little confusing, but the picture should be pretty simple. Now let's compare them to arrays. I really hope you're up to speed on cache locality, otherwise make sure to watch the first video in the series before we move on. We can compare arrays and linked lists along two dimensions. There's performance and there's memory usage. Let's walk through some common operations now. Traversing a list. Although in both cases you're just going over the elements one by one, in the case of the linked list, each node could be literally anywhere in memory. And if it can be anywhere in memory...
I think it probably is better if I just take a break from trying to solve that problem and I focus on studying these hash maps on memories and how the value works, reassigning the values. Because I think that's the issue that I'm having with the way that I'm thinking.
That means that the prefetcher might not be able to cache it for you ahead of time, so there's a potential for a cache miss every single element. So although you're technically taking as many steps, i.e. you're looking at the same number of items, an array is just easier for the CPU to process. Random access.
And on trees is going to be a lot harder because there's recursion as well. So it's going to be connected with the references to these objects.
Yes, this is like, give me the fourth element of the array. Super easy with arrays because you just calculate the address as the base plus the index and you get that memory. But with linked lists, this isn't easy at all. You have to traverse the list starting at the first node. So this really sucks. Insertion and deletion. Here's where things get a little interesting. So with insertion into arrays, unless you're putting something right at the end and you happen to have some free space, then you're going to have to move around the contents of the array. Deleting is pretty much the same deal. A lot of copying and moving elements around if you're trying to preserve the order of the array. With linked lists, if you have a quick way to get to the position you want to insert or delete at, the insertion or deletion itself is trivial. It costs almost nothing. But the trick is you need to have a fast way of getting to that node. So this one, under the right circumstances, is way, way faster than an array. But it has to be under the right circumstances. And it should follow that inserting right at the beginning of a linked list is super easy. But kind of sucks for an array. So a win for linked lists here. Memory-wise, there's some neat things to explore here too. Unless you allocate more space than you need, arrays pretty much exactly represent the data without any extra overhead. But linked lists, each of those nodes means that you have to store the address of the next node, and so linked lists tend to use a little bit more memory. But an interesting thing to note is that, let's say that you've got a small, fixed amount of memory, and you've already done a bunch of allocation in there. So I'll just cross off a bunch of sections as being used already. Now, if you were to try to allocate an array of a few items, you pretty much can't in this situation, but a linked list is really flexible. Each node can be allocated in the space between the used sections. So although technically it uses more memory, there's a flexibility there that the array just doesn't have. Why would I ever choose this over an array? The canned response is to say, you evaluate your needs, and if you need to say do lots of insertions and deletions, go for a linked list, but that's pretty vague. I'll buck the trend a bit and say that not that that advice is wrong, but I'll add that I've actually had very few instances in my career where I've needed a raw linked list. In just about every case, I've started with dynamic arrays and switched over to a linked list as an optimization. In my spatial hash grids video, I originally implemented a lot of this as maps, but switched to arrays of linked lists as a way to massively speed things up. In actual production code, I've done similar things, used linked lists as swap-in replacements in extremely specific circumstances, and I've also used them when trying to write my own memory allocator for fun. When I was at Google, I did a whole bunch of interviews, and one of my favorite questions to give early on before it was banned involved writing a hybrid data structure where the best answer was using a linked list in conjunction with something else. So I won't say that they're super common, but they're an amazing thing to have up your sleeve when the time is right. If you've watched up until this point, it must have been useful, so consider buying me a coffee or something on Patreon. Otherwise, like and subscribe as always, really helps me out. Until next time, cheers.
I guess that's the book I'm looking for as well. A book that explains. Maybe the modern operating system stuff is gonna teach that, but a book that has these things of memory and visualizing the stack and all of this stuff to help me understand. Because I know there's other things with hash maps that maybe overflow, I don't know the name, but where the references get full and then something happens that I don't understand really well.
Hash tables are kind of the next logical step after learning about arrays and linked lists. If you're unfamiliar with hash tables, I find it's really helpful to start by talking about the problem being solved here. Basically, hash tables are a way of storing a bunch of crap and then being able to access it later, quickly, using a key. So the first thing you might be thinking is, hey, wait, that sounds exactly like an array. And that's a good observation. Let's
Right back. We'll go to the bathroom.
look at inserting a bunch of crap into an array. So I dump some items into this array here, and we can access the items later using the index of the array. So the important thing to note here is that the key is the index. But the problem is that this is entirely dependent on the insertion order. If I had inserted them in a different order, their indices or their keys would be different. And the other problem is that if you don't know the index or the key ahead of time, you have to search the array to find what you're looking for. Instead, let's try to compute our own array index using something called a hash function. And this can be literally anything, but let's do something super stupid. And we'll take the name, and I'll just take the length of the name, because I said, super stupid. But you can easily see now where they go in the array. And it doesn't matter what order I insert them in, because we computed our own array index. And we can look up things really quickly. If I want to see if Hermes is in the table, well, the length is 5, so I check that spot in the array, and boom, nothing there. Super fast and easy. But there's some obvious problems here, like what happens when I try to insert Kif? Well, that has 3 letters, and that spot is already taken by Fry. So we need to figure out how to work around this. In a hash table, when 2 separate keys end up hashing to the same index, you have what's called a hash collision, and that's perfectly normal. They can be mitigated against by using...
Yeah, the fundamental thing here that is messing me up is that I'm thinking about this problem in the same way that I think about arrays, because it's a list, and I'm gonna loop over it, but it's obviously a different structure. So the algorithm that I have in my mind for solving these kinds of problems, it doesn't work. It's not the same thing. But then I'm not used to thinking about nested objects in that way. Because usually the stuff that I do most of the time is with lists or things like that. I separate both. I don't encounter situations that often that it's kind of like a mix, and I think linked lists is like this mix of objects with lists, and it's a different way to think about it. And I think that's the reason why I'm struggling with this the most. And the other ones are relatively easier for me, the 2 pointers and the other stuff. Is that this way, I think I haven't thought about a good approach to think about whenever I have both of these structures mixed, to deal with that. And the other problems, I have a natural thing that I already do because I already learned of an algorithm of steps to take to find a solution with the other ones.
Using a better hash function. Our example used an extra stupid one that you'd never use in reality, and there's plenty of great ones out there, but no matter how random your hash function is, you're still screwed because of basic probability, and you're likely to get collisions anyway, so just embrace it and learn to deal with it. And there are a couple major approaches that are used in this case, the first of which is chaining, or separate chaining, and the concept is simple. Instead of allowing you just to store one item at each bucket in the array, or the hash table, here's our hash table again, instead, you make the bucket hold a whole bunch of things. Crazy, I know. For example, you can make each of these buckets its own linked list, capable of holding a whole bunch of crap. Doesn't have to be a linked list either. There's other options. You can make this like a dynamic array. That'd work too. Or really, whatever fancy pants data structure you want. The important thing to note here is that each bucket can contain a whole bunch of items instead of just one. The most obvious downside to this approach then is that when you're doing a lookup and you hash to that bucket, you're going to have to sift through all the crap.
I think I noticed this on the first problem, the breadth first search as well, the depth first search problems, where my first instinct was I had the root node, and I need to get the left-handmost node, so the node at the bottom in the left. And my first instinct was to think about using the index or something like that. And I remember it was the same thing that I got stuck at, which is because the way that I approach the solution is first I think about, if I start from the beginning here and then I go through there, how am I gonna do it? But this way it becomes a problem because you're kind of stuck in the position that you have to begin with initially. Because it's different than arrays where, depending on where you start, you're kind of stuck there because there's all this direct connections you have to take. And with arrays, it's kind of the same thing, but it's a different kind of situation where it's just a linear progression. And objects, it depends on the relationship between them, I think. I think that's the issue that I'm having when thinking about these problems. I need to think about a way to approach it in a different way in my mind. Instead of thinking with arrays, I need to figure out how to come up with something that allows me to think about in steps in the same way that I do with array. About thinking about the pointer and the references instead of thinking about the sequential thing.
That bucket to find what you're looking for, which probably won't be a lot, but who knows. The other generally used approach is something called open addressing, which is a fancy way of saying that you're going to keep trying new buckets until you find a free one. So in our hash table, if this bucket is used, let's say your 2 keys hash to the same bucket again, you just move on to another bucket using some predetermined approach. And for the predetermined approaches, well, there's a few basic ones like linear probing, which literally just means incrementing the index by some fixed amount. That's really, really easy. There's a few other well-known scanning sequences like quadratic and double hashing, which are somewhat self-explanatory. In quadratic probing, you'd increase the array index by some nonlinear value. And in double hashing, your spacing is determined by a second hashing function. There's a whole bunch of others with kind of silly names, which we're not going to go into. Let's just cover the basics of how this works. So yeah, you've got your collision resolution scheme, and they have various upsides and downsides. For example, with open addressing and linear probing, lookups are often slightly faster than most other approaches due to cache effects. Watch the video on memory, cache locality, and why arrays are fast. It should be pretty self-evident. But one thing you can probably guess is that as the table fills up, the performance starts to degrade pretty badly as you search larger chunks of the table. The various approaches have their upsides and downsides. For our purposes, it's sufficient to understand that there are two main...
Yeah, the difference between them is that in arrays, the path you walk is always the same. And with nested objects, it's different depending on the object. So it changes completely the way that I think about it, because Yeah, but I still can't think about a good way to approach nested objects. Because in array you can have this thing that you always do, but in nested objects it's gonna depend on the problem. The steps you have to take, I think. But there must be a way to make it less confusing next time. When I face a similar problem.
Schemes for resolving collisions. Either a bucket holds a single key value pair and the collisions are resolved by moving to another bucket, or we make each bucket hold a whole bunch of key value pairs. Shocking. What you've probably noticed at this point is that there's another problem lurking in the shadows here, which is that the hash table can't be infinitely big. You have to set some fixed size, and as you fill up the table, no matter what collision resolution scheme you use, you'll get collisions, and your performance will degrade, depending on your resolution scheme. Now there's a more proper name for how full the table is, which is load factor. And it's a problem you have to keep your eye on because as the load factor increases, performance decreases, sometimes dramatically after reaching certain thresholds. Basically, your approach at this point, assuming you want to keep allowing new items, is to increase the max size of the table by allocating a larger underlying array and then reinserting every single item into that new array from the old one. And you can do this all at once. Say, once you've passed a certain threshold, you can decide, screw it, we're building the whole thing from scratch. Or you can do it incrementally so there isn't a sudden slowdown. But the gist of it is that at some point, you got to make the table bigger to accommodate more items. And ideally, you want to do this before the table gets too full. Now, if your question is, when do we decide to do that? Well, a common load factor is about 0.75. So when the table is about 3/4 full, it expands. You can choose any threshold you want. Basically, it boils down to being a trade-off between not using excessive memory and not tanking performance. Sparser hash tables waste memory, but operations are snappy, whereas much fuller ones don't waste much memory, but operations could be slower and slower. So now that we've talked about hash tables, what exactly are associative arrays, dictionaries, and all that jazz? Often you'll see these references, especially in higher level languages. Are these hash tables or what? How do they relate to each other? The short answer is, some people group these all together as mostly the same thing. And it's probably harmless to do so. I mean, the practical applications are generally the same, but that'll rile up the pedantic people. So let's dive in a bit here. So there's something called an abstract data type, which is essentially an abstract description of how something is supposed to look and act. Like if I look up an associative array, it's an abstract data type that defines precisely how they're supposed to work. You can see here the operations are listed. You can add, reassign, remove, and look up items using keys or key value pairs. But it tells me nothing about how it's supposed to be implemented, like for realsies, using actual code. It only roughly tells me what operations should be available and the restrictions on them. If I were to say, describe a vehicle abstractly, here's my abstract vehicle, and it's supposed to have some sort of engine, 2 or more wheels, and seat 2 or more passengers. Pretty vague. A car might be the most common implementation of my abstract vehicle, but it doesn't necessarily rule out other implementations. They just might have other trade-offs, or just outright be kind of stupid. But they still meet the vehicle checklist. So associative arrays and dictionaries, they're the abstract description of a kind of data structure, and hash tables are a specific data structure often used as an implementation for associative arrays or dictionaries. So let's talk a little bit about advantages and disadvantages of hash tables now. We'll mostly compare these with arrays and linked lists since we covered those previously, but hash tables are kind of just a great all-purpose data structure. I mean, there's a reason why languages like JavaScript, Python, Go, and many other languages have built-in language-level support for associative arrays. They're just useful as hell. Most operations are, in the average case, pretty fast. Insertions, deletions, and lookups are order 1 constant time. Contrast that to arrays and linked lists, which are fast at some of these operations, slow at others, and it all depends exactly where in the array or link.
Maybe looking at the implementation of different methods in Python as well for lists is gonna help me with this. Understanding the source code behind pop, for example, or push, to understand how they are implemented into the list, because these are things that I just use, but I never think about their implementation and how it works under the hood. And I think that's the biggest issue I have here, the way that I'm thinking. It's because I can break the connections without affecting all the other ones, and I don't really understand how these reassignments really work, or it's hard for me to think about it.
List you're doing things. So the disadvantages now. First off, hash tables are fast. All of the operations are order 1. But if you recall from the video on big O notation, the big O running time of an algorithm isn't everything. For example, on this blog post by Scott Mayers, the author of Effective C++, should you be using something instead of what you should use instead? Scott gives some great examples of just straight up linear searches on arrays beating hash table lookups for small numbers of entries. And remember when we talked about rehashing? So although the average time for insertion is order 1, like all your insertions are chugging along at a nice speed, and then it is of course possible to hit that path where you need to expand and rehash the whole table. So the cost of calling functions could be inconsistent, if that's important to you. There are some other downsides too, like there's no inherent ordering in a hash table, so you can't iterate things in any given order. So if you require things to be in a consistent and reproducible order, hash tables aren't a great fit. I'll avoid babbling about theoretical concerns, which are super unlikely in practice, especially in game development, like uneven hash distributions, which is like, say your hash function hashes a bunch of crap to the same spot over and over again. I mean, it's possible, so I'll mention it, but let's not lose sleep over this. Finally, let's talk about how to use them, and what better way than to actually go through and show you. If you've been following the channel for a while, I've built a few games at this point, mostly showcasing how you can get really far with really simple approaches, and we can go poke around the code a bit on GitHub, looking at some of the use cases for associative arrays. Here's a good first example. In a lot of these projects, I have this entity class that holds a bunch of components, stuff like rendering, physics, that stuff. If you've used Unity, it's basically a poor man's game object system. Anyway, I use an associative array here for the components. There's often quite a few lookups for components by name, and although we iterate the components every frame to update them, the order doesn't matter. Here in the entity manager, I keep a list of all the entities in existence in the game. Those are all just in a big array, but I keep a separate associative array for quick lookups, since there may be hundreds or thousands of entities, and I often want to look up entities by name. Here's another quick and easy one. The finite state machine has an associative array of states, mostly because I refer to states by name. There's not that many, you can just do it with an array, but the syntax for lookups is easy, so I go with associative arrays instead. And finally, here's the spatial hash grid code from a while back. And this is a great example because originally I used an associative array, but here we're using specifically a map in the code in GitHub as the basis for the spatial hash grid. And this was an enormous improvement over doing it the stupid naive way. But at the same time, this is a fantastic example of how these kind of data structures are great as a general purpose, pretty good solution, but can often be beaten out by a custom data structure, which is exactly what we did in this case to squeeze out even more performance. So in general, hash tables, associative arrays, dictionaries, whatever, I just kind of mash them together, sue me. So these, along with dynamic arrays, kind of make up like 99% of the data structures in the games I've been implementing. I tend to just default to an array if I'm going to be iterating things a lot, but not searching for specific items often. Otherwise, an associative array is my other go-to data structure if I need to do a bunch of lookups, but not iterate. Otherwise, at this point, I need to start thinking seriously about being smarter about either my architecture.
So the difficult thing here is figure out good ways to search, to clarify the things that I'm having issue with here. Understanding or trying to come up with.
Why does the code on the top run 10?
I think what I'm gonna do is I'm gonna try for another 1 hour. If I can solve that problem, I'm gonna look at the solution, and then I'm gonna erase the solution, and I already have open here. And I'm gonna search for these things here and try it again. But I need a good way to think about good questions to formulate the stuff that I'm trying to clarify. So I won't be able to search for it directly, I think, because it's something that I think is too nuanced to have a specific video about it. So I have to search for each topic and then try to connect each different part in my mind. So maybe I should understand first the... Yeah, but I wonder if there are gonna be videos about that as well. How array methods under the hoods in Python, like how they're implemented, and then what's the other thing? How re-referencing, but this, I have to figure out a way to break this down. Re-referencing objects change their connections. So for example, in the case of the linked list, I have 1, 2, 3, 4, 5. if I change the value of 3, if I reassign 3 to a different thing, what happens to the pointers of 2 and 4? And the whole, the link, the list itself. Like, do they start pointing to null or to the other different thing that I just reassigned? Because on the illustration is 1 to 2 like this. And this connection here, how it works, I get that is through the method done next, but associating that with the object itself, because in reality is not the arrow, is on each object there is a small arrow pointing, or is inside of the first object, the arrow. No, I'm not sure. I think I still need to spend time as well trying to clarify and figure out exactly the point of confusion I'm having, so I can come up with better questions to ask. Okay, so I'm gonna put the timer here. I'm gonna separate another hour, and then if I can do it, I'm gonna take a break. I'm gonna look at the solution, then I erase the solution. I'm not gonna copy the solution, I'm just gonna look at it, then take a break, go eat something, and then when I come back, I'm gonna study. I'm gonna try to come up during the break. I'm gonna try to come up with questions as well, just try to clarify in my mind what's the difference and the thing that is making this a lot harder for me. And then I'm gonna study that stuff until I'm able to come up with my mind with a approach of a couple of steps that I can take on any of these problems to solve them. So pretty much an algorithm to solve the algorithms. I think that's the best approach to take. Yeah, because I don't think about it consciously, but I think I do have an algorithm to solve array problems. Because I usually do the same kind of stuff. And I think it's kind of like chess, where you have principles, and usually whenever you look at a position in chess, you can see the first thing you should do is look for checks, and then look for hanging pieces and stuff like that. And I imagine that it's pretty much, it works the same way here. So when it comes to arrays, I have my steps that I usually go through. But when it comes to these nested objects, I don't think I have them. And that's why it's a lot more difficult for me. And maybe it's because it's different every time per object, because of this connection, the difference in the connection. Where it's in arrays is always a linear connection, so it's easier to come up with something you can do every time. But for nested objects, now obviously even with lists, the problems itself are always going to be different. But you can take the same kind of approach, I think. And with objects, it's not the same thing, because each object can be a completely different thing. And the way that they are connected can be completely different as well. But there should be a way to think about this. Okay, so let's try again. Think about this this one problem. There are also more methods in arrays, so it doesn't force you to think as well. That might be another reason. Where with arrays would be just as hard if you have to think about the methods you're using, but when you can use all these different methods, it becomes a lot easier. Okay, so current next goes out on next. Which is this thing here. And if I make head, it goes next here. But doesn't work, I think. I think it has to be current on next goes hand here. So I'm making this. I'm making the true equals to the first one. To the current. Then I need to make the current point to the first one. Maybe it's like this. Our prev equals current. I think the issue here is that I'm not changing the value of the head. That's the thing. Each iteration. I'm making the current on x equals head, which is this one. And then I'm making the current, so I'm making the swap here. So I think this part is correct. If I'd made head equals head on x, but I don't think that's is gonna work. Yeah, same thing. And because current dot x is gonna be equal to the whole connection there, and not just the one. So it's 2 pointing to 1, 3, 4, 5. So maybe head should be equal to prav here. Head equals to prav. The thing is, I don't want it to point to none. Or maybe I'm reassigning. So here I have 2, 3, 4, 5, and then I'm reassigning. If I make current on x, it's gonna be equals to 2, 1, 2, 3, 4, 5. Yeah, maybe that's the correct way. So scratch this and then this. I think this is close to the solution. I just need to figure out what should I do with this one. Because I think I'm changing them correctly, but I'm not moving through the first one. Current is equal to this. The next is equal to that. Yeah, I can't change the value of the hand. And then next. Maybe previous equals current. I think I tried that, but it doesn't work. Why making heads equals add-on next? That doesn't work. Or maybe I should do add here. Maybe that's why it's not working. But it should be done at some point. So there's something correct there. Hey man, Absalom. Oh, I should print here. Forgot. I shouldn't have be 1 here. Why is 3? So the only answer has to be because when I make this, it changes the value of the hand. Oh, that easy way to see this is if I print here. Yeah, maybe that's a better way. No, it should be the same thing. So, oh, it's because I'm printing a different thing there. I'm printing current and then it's changing here. I tried with the current as well, but that's not the problem, I think. The problem is that I don't understand how changing the reference to one of them changes the first one, or vice versa. So let me think about what connections should the current .next have. If it is the one, it should be pointed to none. So maybe it should be equal to prav here. And then previous equals that. No, it should be pointed to head actually. But then head's gonna be the whole thing. Maybe head equals previous, and then like this one. Hmm. Head on next equals previous. Equals prav. Or prav equals, no, that doesn't make sense. The head shouldn't be in the loop. But how do I move that? That's the thing that I can't think about. Because how I'm gonna move the pointer from all of them without moving the value of the head? I think that's the thing that I'm stuck at. And that's probably why I'm stuck. It's because on arrays you have to move the pointer as well. In the arrays, when you loop, you're moving the pointer. But here, only way to move from one to the other is by changing the value. That's the reason, I think. The difference and what's making this difficult for me. The current to the head? Huh. Hmm. I didn't think about that as well. Let me think. It's just a dummy node to change the value. Yeah. No, but it's not technically the head, right? It would be like this. You're telling me to do. I need to swap the link each time for both values. So 2 needs to be pointing to 1. So if I make current equals sad.next and then current.next equals sad, I have that switch. But there's something else, because then how do I move from where I'm currently at to the next one? Oh, because current.next equals sad. Yeah, but head equals list node, current equals sad. So it's telling me that I should change this one here. Then start making cur run over the list. Don't touch the head in the loop. Also this. Why would the head interest us in the middle of the list? Oh, because the way that I'm thinking is, and that's probably why I'm having issue. The way that I'm thinking is moving from one to the other one inside the loop. So first I see 1 and 2, then I swap. Then I go from 3 and 4, swap, 4, 5, swap. But the only way to do that is to change the value of the head. That's the problem. And previous equals current here, maybe. Non-type. Here I am making current.next equals next. And then switching the value of the current to this one in here. I think here the issue is that I'm not changing the value of the head again. Because if current.next equals head, it's gonna be equal to this. And then if current.next equals to the head.next is gonna be equal to the 2 there. You need some time to say current.next equals prob. And then next equals prob. So this it should happen sometime, right? If query is true. Yeah, query is true. Then query.next equals head. Should be head, right? Because true should be pointing to one. But then one can't be pointing to all of the other ones. Yes. You want current.next should be one. So I was thinking before like this, but then you got stuck. But before you change current.next, you need to save it before to not lose it in a temp var. Before you change current.next, you need to save it. Okay, so this part is correct, right? I think this one and this one I remember. But the issue is this true here. And the main problem I have is how do I move the head, or how do I move through the loop without changing the value? Or changing the value in a way that doesn't screw up the previous one. This one should be prav, but and prav equals head maybe? The head is not interesting in the middle of the list. So equals current. So let me think about this. So the next one, current is gonna be equal to, the next is gonna be equal to none. So this one is gonna point to none. Sure. And then the previous is gonna be equal to the head. Oh, maybe now it works. Let's see. Yeah, I'm so dumb. It's because I didn't make equal to the head. That's the thing. Because now I can just return previous, I think. Maybe. Yes. There we go. Thank you, man, for the help. I'm glad you just didn't give me the solution as well. So this was the thing that was screwing me up. But I'm glad I spent a bunch of time on this. I think I'm gonna study now the stuff that I was talking about later. Because I think it's messing me up the way that I think. With the pointers and stuff like that. Yeah, but if it wasn't for your help, I wouldn't be able to do it. Maybe it could be also that what screwed me up is that I was trying to mix the previous solution, the solution that I saw, with the way that I'm thinking now. So I was kind of trying to remember what I did in the past and trying to figure out at the same time. and that's why I was confusing the logic of both. Yeah, but before that, I tried a bunch of different stuff as well. So that wasn't the issue. The issue is that I wasn't being able to understand how changing the value, because in my mind before, I did this problem before and I looked at the solution. And the way that I remember the solution and the insight I got from that was that by assigning the value of one of the nodes, I'm actually changing the other ones. And I remember that was something that I thought about after looking at the solution, like, oh, this was a lot simpler than I thought, but for this specific reason, I couldn't solve it. And then I was trying to think about that while solving this one. And that was messing me up because I thought the problem I had here is whenever you change one node in the linked list, it's going to change all the other ones. And it's really hard for me to think about this connection because in array is one way, and with nested objects is a completely different approach. So it's very confusing. And I also have the same problem with trees as well, where I noticed that my first inclination when I encounter a tree problem is to start from the beginning, from the left to right, but it's kind of like you're stuck in the point that you begin, and to be able to traverse to different points and run the logic from there is a lot harder, because in array you can just use the index. And that's the biggest issue I have, I think. It's a different way of thinking, and I'm not used to thinking in that way, because I don't deal with nested objects a lot when I'm building things. But it was really good to spend a bunch of time on this. This exercise is confusing. I hope you didn't know if it would work before I clicked. Yeah. Thanks, man. Thanks a lot. I think before moving on to the next ones, I'm going to study this stuff here. I think it's going to help me. What I want to do is figure out a way to think, because in problems with lists and arrays, I have a way to think about them, but it's not like I'm consciously thinking. It's more, I think because I solved a bunch of problems, I already think about certain things that I'm going to do with the indexes and the looping stuff. But for nested objects, I don't have that same same line of thought. When you first encounter the problem, and you're thinking about what steps you can take, how you can navigate through the problem to solve it, I kind of get stuck with nested objects. And I need a way to clarify that, I think. Because the issue is the connection is always going to be different. There's going to have patterns there. For example, in trees, it's always going to be left to right. So the structure of the object stays the same. But the way you navigate is a little bit, is a lot harder for me to understand. Because you can't think about this the same way that you think with arrays going from left to right. You have to think about the navigation of the objects and their references. Yeah, so I think I'm going to look at the solution for this one, and I'm going to take a break, and after I take this break, I'm going to study this stuff before moving on to the next ones. I'm going to see if I can come up with a good mental approach to think about these problems. Like different ways that I can try to traverse through nested objects, and how do they work, I think. It's probably gonna help a lot.
Hey everyone, welcome back, and let's write some more LeetCode today. It's actually raining outside right now, pretty hard, so hopefully you can't hear it too well. So today let's solve an easy question, reverse a linked list. And this question is actually like a sub-problem that's needed in a lot of other questions, like linked list related questions, so it's definitely good to understand. So just like the problem says, we have a linked list, we've got some nodes, and we just want to take each of these links, reverse them, keep doing that with every link, and then this is going to be the new head, and then we're going to return that. And they tell us that this can be done two ways, iteratively, meaning with just pointers, and also recursively. And I'll show you how to do it both ways. So we can do this with two pointers because we want to reverse it. So like from the perspective of this node, instead of the next pointer pointing at 3, we want it to point at the previous node 1. So if we want to do this iteratively, we can use two pointers like many problems. Now, what are the two pointers going to be? We can have initially a current pointer, so we can initialize current to the first node, which is our head. And we can also maintain a previous pointer, which initially is going to be set to null. So for the first node 1, we're going to take the next pointer and reverse it. So now the next pointer is going to be pointing at null. So this is now going to be the last element in our new reversed linked list. So now we can shift our pointers. So we're going to take the previous pointer and then shift it to current, and we're going to take the current pointer and shift it to the next node. Now, since we broke this link, we have to save this somewhere before we end up breaking this link. I'm going to show you how to do that in the code. So now our current is 2. We want to take the next pointer and reverse it. So the next is now going to be like this. So it's going to point at previous. So we can reverse the next pointer and set it to previous. And once again, we're going to shift our previous pointer to current, and our current pointer is going to be shifted to next. Now we're finally at the last node. We can once again update the next pointer of this current node. And so now when we update our pointers, previous will be here and current is going to be at null. We've reached the end of our list. Now we want to return the head. How do we return the head? Lucky for us, the previous pointer is equal to the new head, right? So this is going to be our result. Just like in the drawing, we can initialize our pointers first. Previous will initially be null. Current will start at the head. And we want to keep going until we reach the end of the list. So while current is not null, we're going to reverse the pointers. So we want current.next to be set to previous, and then we can shift our pointers, right? So we can update previous, set it to cur, and cur is going to be equal to current.next. But notice how we set current.next to previous before. So when we do this, we actually are going to have a temporary variable called next, which I will do at the first line when we start our loop. So we can save that in next. So then when we update current.next, we still have that next pointer. And lastly, we return the result, which we know is stored in previous when this loop stops executing. So it works, and this is actually the most optimal solution. The time complexity is big O of n.
And the other thing that I wasn't understanding, maybe that's why I had issues as well, because I was trying to incorporate some parts that I remembered from this solution into the next one, into the one that I was trying to do, which is how I'm gonna move the pointer inside of the loop if I'm not changing the value of the head, but yeah. But that's the thing, is he starts at the head with the current. So he is changing the value of the head, but not directly. But I wonder, so it should be the same thing if you do it without the current variable? But then you're just changing the initial list? So if I erase this stuff here, so why do I have the current there? Just because you're changing the initial list? Yeah, I'll think about this. I'm gonna take a break. And when I come back, I'm gonna study this stuff here. And potentially continue to do the list. Yeah, so see you soon.